Hello everyone. Today's topic is straight lines. It's a high school level topic. We are talking about the geometry, actually Euclidean geometry. What you have learned in your school level is the Euclidean geometry. So you are doing Euclidean geometry right now. So we'll talk about straight lines. Before that, we have a small introduction. What do you mean by coordinate geometry? Actually, coordinate geometry is the coordination of algebra and geometry. Actually, a lot of calculation coordinates actually are introduced to help geometry actually, and there are various types of geometry. Actually, in two dimension, you are doing a two-dimensional geometry. Later on in your syllabus, there is a three-dimensional geometry. So we'll talk about the three-dimensional geometry also. So here, actually, we'll restrict ourselves to two-dimensional rectangular system. You have polar coordinate system also, but we are here. I am discussing Cartesian coordinate system. So in Cartesian coordinate system, you have a axis, two perpendicular axes. That is why at right angles. That is why the system also sometimes called orthogonal or rectangular. So let me draw the coordinate system. So this is the coordinate system. You know that you have learned that this is the origin, this is x axis, and this side x prime o x, this is the x axis, y o y prime is the y axis. If you go in the left, it will be negative, x is negative, right you will x is positive, up y is positive, down y is negative. So this is the origin. You have to start from here. So this is your first quadrant, second quadrant, third quadrant and fourth quadrant. And you know that in the first quadrant all the points are positive, and points are denoted by actually px comma y. These are the points of the Cartesian coordinate system. So if your point is this, then you know this distance is x, right? And if you go up, this distance is y. So that's how you can get the point x comma y, any point on the coordinate system. And this is your Cartesian coordinate system. This is also called orthogonal system or rectangular system because of this angle is perpendicular. Otherwise it is called oblique system. Okay, so this is the basic introduction. Let me introduce with some few formulae that already known to you. First one is the distance formula between 2 points P and Q. So you have a point P and you have a point Q. So if you connect this with a straight line, then the distance is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. It's a positive square root because distance cannot be negative. So this is the distance formula. You have a section formula, mx2 plus nx1 by m plus n. Actually the coordinates of the point of intersection. How? Actually divides, this P point divides the segment joining the points A and B internally. You look at that, it is internally in the ratio m is to n. So let me show you how it is intersect internally. Okay, so for that let me draw one axis once again, coordinate axis. So you have a point A and B, and this is the segment joining A and B. Point of coordinate of A is x1 y1 and B is x2 y2, right? And this is the point P. P is the point, P cuts the line in the ratio m is to n. This is called internally cuts the ratio, cuts. So if it cuts internally in the ratio m is to n, then the formula will be plus mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Okay, got it? You look at that, m goes to m with x2, n with x1, m with x2, m with y x1, like this. And if it cuts externally, what do you mean by externally? Externally means this is the point P and this is your point A and this is your B. So this is called externally. The point is outside the segment actually. So in this case, this ratio is m and this ratio is n. Okay, in that case you have a negative sign here. In that case your positive sign will be replaced by a negative sign. If it is externally, then your P point will be, if your P coordinate of P will be mx2 minus nx1 by m plus n, right? M minus n. All the things will be in negative. Okay, so m minus n comma my2 minus ny1 by m minus n. Okay, so this is the thing if it goes externally, if it cuts externally. And the special case is that if it is a midpoint, then 1:1 is the ratio. In that case, your midpoint formula gives the midpoint p is given by x1 plus x2 by 2, y1 plus y2 by 2, because m is 1, n is 1. So that is how you can get the midpoint. Okay, next, you know that this is the area of the triangle. You can get the area of the triangle in Cartesian coordinate system. This is the triangle, this is the coordinates, and this is the points A, B, C. If your coordinates of A, B, C are given by x1, y1, x2, y2, x3, y3, then the area of the triangle, numerical value of the expression, is given by half x1, y2 minus y3, x2, y3 minus y1, x3, y1 minus y2. So this is the area of the triangle. And if the points are collinear, you can get the condition of collinearity from here. You can get the condition of collinearity. So let me write condition of collinearity. You can get the condition of collinearity is that area of the triangle equal to 0. Area of triangle equal to 0. That is the condition of collinearity. So 3 points will be collinear if their area of the triangle, this value equal to 0. If this value equal to 0, then the points x1, x2, y, x3, you cannot form a triangle with the points, but you will get the lines in the straight line. The lines form a collinearity. So the line, they will lie in one line only, x1, y1, x2, y2 and x3, y3, right? So this is how you can get the collinearity, condition of collinearity. Now I will talk about centroid. Some centers connected with triangle. This is very important topic because say this is needed in solving some problems. Centers connected with a triangle. Centers connected with a triangle. So first one is most important one is centroid. What is the centroid? The point of concurrency of the medians of a triangle is called the centroid of a triangle. Okay, the centroid of a triangle divides each median in the ratio 2:1, and the coordinates of the centroid are given by g. G is equivalent to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Let me prove this one. It's a very simple proof. Let me show you the idea. So what is the centroid? Centroid is the point of concurrency of the medians of a triangle. It's called the centroid of a triangle. Okay, okay, so let me draw a rectangular axis. Let me take a triangle, any triangle it can be. So your triangles are ABC is the triangle, the vertices are ABC, x1 y1, A vertices is x1 y1, B is x2 y2, okay, and C is x3 y3. These are the coordinates of the vertices. Now AD is one of the median. AD is one of the median, and this is suppose G. Okay, this is suppose G, and this ratio is 2:1. Okay, G divides the segment in the ratio 2:1. So we'll have to find the coordinates of G, that x1 plus x2 plus x3 by 3. Okay, D is the midpoint of BC, right? Because you see the point of concurrency of the medians of a triangle is called the centroid of the triangle. And what is the median? Median is the line joining the vertices to the midpoint of the opposite side. Median is the line joining the vertices, opposite vertices, to the opposite midpoint of the sides. So D, what is the coordinate of D? Coordinate of D will be x2 plus x3 by 2, comma y2 plus y3 by 2, right? This is the midpoint formula I am using. Now you apply the coordinate. What is the coordinate of G? So look at that. AD actually, AD is divided into AG is to GD. What is the ratio? Ratio is 2:1. Right? Now what is the coordinate of G? If you apply the section formula, so x1, right? x1 into 1. So I am writing that x1 into x1 plus 2 into x2 plus y3 by 2, because coordinate of D is x2 plus x3 by 2, right, by 1 plus 2, and the same thing is for y coordinate, that is 1 into y1 plus 2 into y2 sorry plus y3 by 2 by 1 plus 2, right? So you will get G, this 2 got cancelled, you will get x1 plus x2 plus x3, sorry, this is 2 plus x3 by 3, 2 plus 1 3, and the same thing is happening for the y also, y1 plus y2 plus y3 by 3. So that is proof. The centroid has a coordinate, G x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So always remember, the point of concurrency of the medians of a triangle is called the centroid of the triangle. That is the very important part, center of the triangle. Okay, next one is orthocenter. What is the orthocenter? The point of concurrency of the altitudes of a triangles are called the orthocenter of the triangle. So in this case, you see I have drawn one median. You can take other medians also, they will pass through one point. That is the meaning of the concurrency, right? So they will pass through the same point G, and G has the coordinate x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So what is orthocenter? Orthocenter is basically the perpendiculars from the opposite, from the vertices to the opposite sides. So that is why it is called concurrency of the altitudes of triangles, is called the orthocenter of the triangle. And the orthocenter coordinates of the orthocenter are given by this formula. I am not going to prove this. You can prove it similarly using your trigonometric relations. x1 tan A plus x2 tan B plus x3 tan C by tan A plus tan B plus tan C, and that is the same thing is for y1, y2, y3. And what is the diagram for orthocenter? Let me draw a diagram for the orthocenter. Let me show you. This is the triangle, and you see the triangle is, this is the perpendicular from opposite vertices A, B and C, and this is the perpendicular from the opposite vertices. Again you have a perpendicular from the opposite vertices, right? So these three will intersect at one point. They will pass through one point. That point is called the orthocenter actually. Orthocenter. That means you are drawing the perpendicular. This is 90 degree. You are drawing the perpendicular from the vertices to the opposite sides, and the point of concurrency of the altitudes of triangles are called the orthocenter of the triangle. Okay. Next I will talk about the incenter. So incenter is basically the center of the circle which is inside, in center of the circle that is inside the triangle. So point of concurrency of the internal bisectors of the angles. Internal bisectors of the angle is called, of a triangle, is called the incenter of the triangle. So we can draw the incenter. So this is the triangle, suppose this is the triangle, ABC is the triangle, okay, and you see this is the incenter. Okay, I am not, yeah, it is not so good. You can draw like this. Yeah, this is the incenter, this is the I, and this you will get by internal bisectors of the angles. So if you draw the internal bisectors of the angles, they will intersect at a point, and that point is called, the point of concurrence is called the incenter of the triangle. So similarly you can prove that incenter is given by, just I give you the idea how to prove. You can use that and prove it. Ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. So this, where ABC are the sides, these sides are ABC actually, this is ABC, the length of the sides, this length of the sides, and the capital ABC are the angles and small ABC are the sides. So this is called the incenter. So always remember, incenter is the concurrency of the internal bisectors of the angles of a triangle. And what about the circumcenter? Circumcenter is given by a point which is equidistant from the vertices of a triangle. Circumcenter pxy is a point which is equidistant from the vertices of a triangle, that is the side bisector. Side bisectors will give you the circumcenter. So circumcenter is a point which is equidistant from the vertices of the triangle ABC. So circumcenter actually, you can draw the circumcenter for a triangle. Suppose this is the triangle, any triangle you can take and draw the circumcircle. So you can get the circumcenter by this. This is the side bisector actually. So this pass through one of the point, that point is called the circumcenter, and circumcenter is equidistance from the vertices of a triangle. You look at that, circumcenter is equidistance from the vertices of a triangle. That is a very important result actually. With the help of this result you can solve many problems. Circumcenter is equidistance from the vertices of a triangle, and circumcenter is given by x1 sine 2a. In that case, you see in orthocenter we have used tan, trigonometric tan, you see tan. So in circumcenter we are using sine 2a, sine 2b, sine 2c, and y1, y2, y3 same, sine 2a plus sine 2b. So ABC, angle ABC are the angles, twice a, twice b, twice c. So this is how you can try this proof. Okay, so we'll talk about, we have already talked about centroid of a triangle, incenter of a triangle, orthocenter of a triangle, and circumcenter of a triangle. So these four things are very, very important for the triangles, centers. And important observations, I will draw one important observations here. So your circumcenter O, centroids G, and orthocenter of a triangle are collinear. So you see that this is your circumcenter and this is your centroid and this is your orthocenter. They are always in a line, always in a straight line. So they are collinear. So your circumcenter O, centroid G, and orthocenter are collinear, and G divides OH in the ratio 1:2. So this is 1, this is 2. Okay, OG is to GH is 1:2, and this is sometimes called Eulerian line. Euler actually, the great mathematician who discovered this. So this is sometimes called Eulerian line. And next important note is that in an isosceles triangle, isosceles, that is the two sides are equal, centroid, orthocenter, incenter, circumcenter lie on the same line. So for isosceles triangle the 4 points are in the same line, that is they are collinear, and for equilateral triangle they will coincide. So they are the same point, they will coincide. For equilateral triangle they will coincide. So these are the two important notes, please remember. Next, in the last part of our lecture today, I will discuss locus. What is the locus of a point actually? So locus actually, when a point moves in a plane under certain geometrical conditions, the point traces out a path. Okay, when a point moves in a plane means it can be your two-dimensional page or your page from your exercise book. So that is a sense of plane. When a point moves in a plane under certain geometrical conditions, the point traces out a path. This path of the moving point is called its locus. Just like if I explain mm, suppose elliptic. Yeah, your sun is here and earth moves around the suns like this is the locus of the path, and if you join the path you will get a elliptic nature. This is called the locus of the or planets. All the planets revolve like this, right? All the planets revolve like this. Sun is at the focus, so this is the locus. Actually at different type, at different position, you just dot, you mention the points at the space, and if you draw the space, if you draw the region, if you draw the diagram, then you will get a curve nature. That curve is called the locus of the point. Okay. And what about equation of a locus of a point? The equation to a locus is the relation which exists between the coordinates of any point on the path and which holds for no other point except those lying on the path. In other words, equation to a curve or locus is merely the equation connecting the x and y coordinates of every point on the curve. So this is how locus, and this is how you can get the equation of a locus to a point. So let me explain with a problem, then that will be far better for you. So let me explain with a problem. Yeah, I have a problem with you for you. The sum of the squares of the distances of a moving point from two fixed points a0 and minus a0 is equal to a constant quantity 2c square. Find the equation to its locus. So the sum of the squares of the distances of a moving point. So I am talking about a moving point. Let me take one moving point here. So first let me take a axis. So this is your moving point P, and its distance from a0 and minus a0, right? So a0 is here and minus a0 is here, right? This is your minus a0 on the negative direction, and this is your a0. So from these 2 points, if you draw the distance, if you take the distances, this is sum of the distance, square of the distances is constant. That is given in the problem. Okay. Let the moving point be h comma k. Always in the locus problem we used to take h comma k as the coordinate of the point, moving point. It's a moving point. It can be anywhere. It can be anywhere. It can be here, it can be here, it can be here. Let's verify the locus of the curve. So P is the point h comma k. So this is your A point, this is your B point, and it is given that PA square plus PB square equal to 2C square, right? It is given PA square plus P. You look at that. Square, sum of the squares of the distances, sum of the squares of the distances that is mentioned is a constant 2c square. So if you apply the distance formula, what you have, ph minus a whole square, right, plus k minus 0 whole square, right, plus the next one is h plus a, because this is minus a. So h plus a whole square plus k minus 0 whole square equal to 2c square, right? So if you simplify, if you expand, you will get h square plus k square, because you have twice h square, twice k square, and twice a square, twice c square. So you have c square minus a square, right? Hence the locus is, that means you have to write at the last line, hence the locus of h comma k is, you have to replace this hk by xy, right? That what we mean, x square plus y square is equal to c square minus a square. So this is the required locus. This is the required locus of the point, moving point h comma k. Okay, clear? So that is the concept of the locus, and this is the solution of the problem given. Let me give you another idea, another problem. This is the last problem today. So let me give you the idea. A rod of length L slides with its ends onto perpendicular lines. Find the locus of the midpoint. So let me take the coordinate axis of the perpendicular lines, and this is the line L. L is the length of the line. The rod of L slides with its two ends. These two ends are sliding. So let us take these 2 points as a comma 0. This is the coordinate, x coordinate is a comma 0, and this is 0 comma b, right? Then you can get the okay, you have to check, find the locus of the midpoint. Let the midpoint be, let me draw 1 second for your better understanding. So this is the point a comma 0 is the point, and this is the point b. This is your 0 comma b, right? And this is the midpoint. Suppose midpoint is moving. If this rod slides, then this point will slide, right? This point will change. So we'll have to check what is the locus of P, and let the coordinate of P be h comma k, right? And it is given, the length AB is given, AB equal to L, right? AB equal to L, and h equal to, you look at that, h is the midpoint of AB, so h equal to a plus 0 by 2 and k equal to 0 plus b by 2, right? 0 plus b by 2. So you have from triangle, this is a right angle triangle, you apply Pythagoras, so you have OA square plus OB square equal to L square, because L is your AB, this is your origin. So you have OA is a square plus b square equal to L square. And what is your A? A is your twice h, so you have 4h square plus 4k square equal to L square. So hence the required locus is, you write the same statement here also, hence the required locus is, 4x square plus 4y square equal to L square. Okay, got it? So this is the concept of the locus of HK. You have to mention locus of HK, that is the midpoint. So midpoint of HK, so that is represents a curve. The curve is actually in this case you have a ellipse, or in this case you can get the circle also. Circle is a special case of ellipse. Okay, so this is how, this is the introduction to the straight line, that is the basic introduction. I haven't started the straight line now, but in the next video I will start the straight line. So this is the previous prerequisite before you start the straight line. Thank you all of you.